Okay, welcome to our classroom. Again, before we start, let's start with a prayer. Lord Jesus, I pray today that you multiply your grace on me, subtract and take away all of my sins by your mercy you have shed on me. Add to my awareness a better understanding of your will for me in my life. I will divide my blessings and grace with those that are not as fortunate as I am. In your perfect and most holy name, I come to you, Jesus, and ask these things. Amen. Again, I'm your grade 7 mathematics teacher, Maria Eliza Nunez. Our objectives for the afternoon sessions are illustrates the different properties of operations on integers, change rational numbers from fraction form to decimal form, and vice versa. Okay, before we go with our topic, I would like you to reflect on this. Give at least 5 words synonymous to the word property. Take a look at this illustration. We have 5 plus 3 equals 8. 3 plus 5 equals 8. I have the following question for that illustration. First, what operation is used in illustrating the diagram? Second, what happened to the terms in both sides of the equation? Third, what if the operation is replaced by multiplication? Will the same property be applicable? Give an example to prove your answer. Fourth, define the property. Fifth, give a real-life situation in which the commutative property can be applied. And lastly, test the property on subtraction and division by using simple examples. What did you discover? I have here another Venn diagram. I mean diagram only, not Venn diagram. Quantity 3 plus 4 plus 5 equals 12. Another, quantity 4 plus 5 plus 3 equals 12. First, what operation is used in illustrating the diagram? The same question a while ago. What happened to the groupings of the given sets that correspond to both sides of the equation? Number 3, what if the operation is replaced by multiplication? Will the same property be applicable? Give an example to prove your answer. Number 4, define the property. Number 5, give a real-life situation in which the associative property can be applied. And lastly, test the property on subtraction and division by using simple examples. What did you discover? We have here another diagram. 3 times quantity 2 plus 3 is also equal to 3 times 2 plus 3 times 3. How? Okay, let us try to explain. If I add first 2 plus 3, the answer will be 5. And if I multiply it to 3, the answer is 15. On the other side, if I times 2, 3 times 2 is 6. 3 times 3 is 9. If I add it, the answer will be, again, 15. That's why they are the same. First, let us define the property. Second, in the said property, can we add or subtract the numbers inside the parentheses and then multiply or perform multiplication first and then addition or subtraction? Give an example to prove your answer. And lastly, give a real-life situation wherein distributive property can be applied. Another illustration, if I have 5 kids plus nothing to add at all, the answer will still be 5. And the question for that illustration are this. First, what will be the result if you add something represented by any number to nothing represented by 0? What do you call 0 in this case? Define the property. Is there a number multiplied to any number that will result to that same number? Give examples. What property is being illustrated? Define. What do you call 1 in this case? Another illustration using the chips. If I have 1 yellow chip and 1 red chip, that means positive 1 and negative 1 is equal to 0. If I have 4 yellow chips and 4 red chips, that will means positive 4 and negative 4 equals 0. Here are the questions. What will be the result if you add something to its negative? What do you call the opposite of a number in terms of sign? What is the opposite of a number represented by A? Define the property. What do you mean by the reciprocal and what is the other term used for it? What if you multiply a number, say 4, by its multiplicative inverse 1/4? What will be the result? And lastly, what property is being illustrated? Define. Okay, those are the properties of the operations on integers. Again, let us summarize those properties. Let us start with the closure property. The closure is simply as it is, like the sum or product of any two real numbers is also a real number, of course. For example, if I have a plus b is a unique real number, so the answer C is also a unique real number. If I have A times B is a unique real number, again C is a unique real number. Next, if I have commutative property. Commutative property, I'll just talk about the order of the addends from the word commutative, commute. The order of the addends or factors does not affect the sum or product. For example, if I have a plus b equals b plus a, or a number, if I have 1 plus 2 is also equal to 2 plus 1. The same goes with our multiplication. If I have ab equals ba, or 1 times 2 equals 2 times 1. But if I use it in subtraction and division, it will not be applicable. Why? Because if I have 1 minus 2, it is not equal to your 2 minus 1. The same goes if I have 4 divided by 1. Is it not equal to your 1 divided by 4. That's why this property is only for addition and multiplication. Next, if I have the associative property, the grouping of the addends or factors does not affect the sum or product. Again, this property is only for addition and multiplication. Okay, if I have A plus quantity B plus C is equal also if I have quantity A plus B plus C, or if I have 1 plus quantity 2 plus 3 is also equal to quantity 1 plus 2 plus 3. The same goes with your multiplication. Next is our distributive property. Distributive property states that multiplying a number to the sum or difference of a number is the same as multiplying the number first, then finding their sum or difference. That's what's on the illustration a while ago. Next, identity property. Any number added to 0 is equal to the number itself. Therefore, that 0 is called the identity element of addition. While in our multiplication, we also have it. Any number multiplied to 1 is equal to the number itself. 1 is called the identity element of multiplication. Next, lastly, we have the inverse property. Inverse property, the sum of a number and its opposite is 0. So for example, if I have 1 plus negative 1, it is always equal to 0. If I have the product of a number and its reciprocal is 1, if I have 1, or rather 2 times 1/2, the answer is 1. Okay, let us try to answer this. Which operation will not change the value of any non-zero number? Letter A, multiplying by 1. Letter B, multiplying by 0. Letter C, dividing by 0. Or letter D, adding 1. Next. Which equation shows the commutative property? Letter A, 7 times 3 equals 7 plus 7 plus 7. Letter B, 4 times 2 equals 2 times 4. Letter C, 8 times 9 minus 6 times 9 equals quantity 8 minus 6 times 9. Or letter D, 3 times 1 equals 3. Next, number 3. Which property of addition is used in the given? Quantity 4 plus 9 plus 7 is equal to 4 plus quantity 9 plus 7. Letter A, commutative property. Letter B, associative property. Letter C, distributive property. Or letter D, identity property. For number 4, which property of addition does 2 plus 0 equals 2? Illustrate. Letter A, 0 property. Letter B, identity property. Letter C, distributive property, or letter D, commutative property. Next, for the last one, which property would you use to simplify the given expression to quantity y plus 4? Letter A, distributive property. Letter B, commutative property. Letter C, inverse property. Letter D, associative property. After having those property, of course, let us proceed to our second objectives, changing fractions to decimals and vice versa. Fractions and decimals are called or members of the rational numbers. Okay, we have here examples: 1/2, 4/5, 3/11, 1/3, and 3/4. Okay, let me have it. Let me solve it for you. Okay. For example, here is our 1/2. So you will divide 1 and 2. Okay. Okay, to look like this, 1 divided by 2. Since it cannot be divided, you need to add a decimal point and 0. Okay, now you have 10 divided by 2. This time it can be divided. So 10 divided by 2 equals 5. So 1/2 is equal to 0.5 when being changed into decimal form. Let us move to our 4/5. Okay, as you can see, it is the same. 4 cannot be divided easily to 5, so you need to add decimal and 0. So now you have 40 divided by 5. So 40 divided by 5 is 8. So your answer now will be 0.8 or 0.8. Next we have 3/11. So it will look like this: 3 divided by 11. So since it is not, again, divisible, so you need to add decimal and 0. Okay, now you have 30 divided by 11. So you can have 0.2. 0.2 first. Okay, let us see. 0.2. As you can see, if I have 2 times 11, it will give us 22. Then you need to subtract. So 30 minus 22 is 8. Since there's still remaining 8, add another 0. Divide it again. So you have 80 divided by 11. On 80 you have 7. 7. Okay, on 80 you have 7 11. That is, okay, so we have 7 times 11 is 77. And if you subtract it again, you will find you go back having the 3. So if you find that you go back having that 3, that means you will have a repeating decimal. So to write a repeating decimal, just put a bar on top of your answer. Okay, so that's how it looks. 0.27 repeating. Okay, our first two example is not repeating. That is what we call terminating, when it stopped. But if it didn't stop, that means you have a repeating decimal. Okay, next example is 1/3. Okay, let us move to our next example, 1/3 or 1 divided by 3. Again, you need to add point and a 0. So this time you have 10 divided by 3. Your answer will be 3. 3 times 3 is 9. Okay, so 3 times 3 is 9. So 10 minus 9 is 1. So we will go back again having that 1. So that means 1/3 is also an example of repeating. So you need to put a bar on top of 0.3. Okay, so that will be our answer for the number 4 example. How about the last one? The last example is 3/4 or 3 divided by 4. So need add again point and 0. Okay, so you have this time 30 divided by 4. How many 4 do we have in 30? So that means we have 7 4. And then 7 times 4, you will have 28. And then 30 minus 28, you will have 2. After the 30 minus 28, you have 2. Add another 0 on the 2. Then divide it again into your 4. So you have 5. Put it on top beside the 7. And as you can see, if I have 5 times 4, that is 20. And 20 minus 20 is 0. So our answer will be 0.75. Again, it is a terminating decimal because it stopped. So that's how you change fractions into decimal. You just divide it. Always remember that. Okay, how about if I will change a decimal into fraction? So this is how we do it now. Okay, for example, I have 0.8. We all know that in decimals places, we start with tenths, hundreds, thousandths, and so on. So if it is 0.8, that means it is on the tenths place. So you will write it in fraction as 8 over 10. And in fraction, we always have the term simplify if it is possible. 8 over 10 can be simplified by dividing them into 2. So 8 divided by 2 is 4. 10 divided by 2 is 5. So your answer will be 4 over 5. Okay, that's how you change it. How about if I have 4.2? Take 4 as a whole number. So this time you will have a mixed fraction like this. So you have 4, 2, 4 and 2 tenths. But because it is still divisible, the 2 tenths, so you'll have 4 and 1/5. Okay, next, let us have the last example, 5.12. By 5.12, so you will have 5, 12 over 100. And 12 over 100 can be simplified again by dividing it into 4. Okay, 12 divided by 4 is 3, and 100 divided by 4 is 25. Therefore, there is no more simplification. So your final answer will be 5 and 3 over 25. So again, that's how you change decimals into fraction. Next. Next is for your quiz time. So this will be your quiz for the afternoon session. Activity 1. Name the property illustrated in each of the following. Next. Okay, next. try something more? Use the indicated property to write an expression that is equivalent to each of the following expressions. Next. Okay, activity 2, convert to fractions. Okay, I want you to show your solution. And lastly, activity 3 is another riddle. The question is, why can't a bank keep secrets? To find out, express each rational number as terminating or repeating decimal. Find the answer under the blanks. Write the letters of the problem on the blanks. Okay, here are the blanks. Because there are. And finally, after having this lesson, I want you to make another reflection. Again, you can choose video blog, narrative post, photo journal, or to your preferred reflective mode of documentation. Just state the 3 statements. I learned that, blank. I realized that, blank. I will do, blank. And finally, we can say, madaling-madali ang math, as simple as that. Again, I'm your teacher, Maria Eliza Nunez, now signing off.